Let's go live. Yes, I think we should be good. We should be good here. We should be good. Hello, as you see my cascading screen here. Hello again. Make sure we're good here. Get started in about 30 seconds with this third part. Third part here. Get my part uploaded so that we are good. Good. Just making sure we're good being live here. I just want to make sure I'm good on my end here so I can hear and see myself. I think there we go. It's taking forever. What's up, Mr. Nelson? So you can see me good, see and hear me? I'm trying to bring it on my phone here, and I'm not seeing the live notification go up, unless just because I'm, like I said, unless just because I'm kind of this would be the third go around here, and YouTube must not like that for some reason. I appreciate that. I explained that last stream there. It's a tool called EpicPen. It's called EpicPen. I mean, it's very. So for me, I have a Windows type. It's an HP screen, so I'm able to write on that. It says I'm live, but I can't bring it up on my phone. I'm trying to do this on my phone so I can see it. For some reason, it's telling me that I have a. Okay, cool. Thank you. All right, I see you there. So I'm going to get started. You can see and you can hear me, which is great. I'm going to get talking about the actual stream that fully worked yesterday. Which was talking about in the 8th grade stanza of things was solving equations with variables on both sides. So, like for instance, let's go with an example. Let's go with an example of 4x plus 2 equals, let's say, 3x plus 6. So in this instance, right here, let me move my icon out of the way. Okay, if we're solving for x, we have to make sure that we get x to one side. You got to get x to one side. So it's purely order of operations on this. So if you see a positive 3x on this side, you're going to then subtract 3x from both sides. And if you remember yesterday, those of you who are following along with me on the stream there, that you're able to see the little digital tool we were using to see the little tiles, and you're able to take the tiles and bring them down to where you're able to subtract from both sides. It was a good visual way of seeing things. I liked it. I mean, it's like I said, it's a different way of seeing things, and we all learn differently. But needless to say, let's get to this. 3x minus 3x is 0, so all you're left with is a 6 on the right side. So a 6 on the right side. On the left, 4x minus 3x is x. X plus 2 equals 6. Well, you're not done yet. You have to get x totally by itself. If you have a plus 2 on the left side, how are you going to, as I said in the class, kick that to the other side? Well, you have to subtract 2 from both sides. So when you subtract 2 from both sides, those cancel, and you're left with x equals 4. And again, this was what we were going over yesterday. Pretty much, I mean, everything kind of follows that same path with things. Use your inverse operations, but you have to get x to one side. So whether it's having to kick a negative to one side or kicking a positive to the other, I mean, just taking it one step at a time. Try not to look at the whole thing and go, oh my God, there's 10 different things going on, but you just have to take it one step at a time. Just trying to look at my phone. I cannot find the stream on here, which is a little bit troubling, but needless to say, so if I'm seeing this, just kind of let me know if something isn't coming up or if something is going on, or just shoot me a text, anybody else who is on here, just so I know. Needless to say, let's clear the screen. So what I'm going to be talking about here, so what I'm going to be talking about is the yard sale packet, I'm going to try to get through a few pages. I mean, obviously there's not enough. I could sit here all day and go through every single page, but I know that Miss Holden is going through some as well, so I'm going to take a few of the other ones and just kind of, we're going to break these things down to where, you know, it helps you guys out. I mean, this whole scenario is new for all of us. So let's open this up. Let's open the yard sale packet up here. Let's zoom in. And the one that I really wanted to kind of get started with and really review, and sorry for the nauseating ride down there of me doing that, but let's do the one that's called Miller's Front Yard, or Miss Miller's Front Yard. Just kidding. So Miss Miller's Front Yard. Miller's Front Yard. So the Miller family. So the Miller family wants to know how large the front yard is so that they can decide how many tables to rent for the neighborhood yard sale. So you may need to divide the yard into two parts to find the area. What this is about, so ladies and gentlemen, what this is about. It's about taking what we call an irregular polygon. So a polygon to where you're seeing it here, and you're like, well, I can't go, well, length times width is going to give me the area for the whole thing. It doesn't work that way. There's no specific formula that's going to give me the area for this specific polygon. So what we have to do is we have to split this into dimensions and shapes that we do know the formula for. So let's clear this off. So the question becomes, well, how do we want to split this? So how do we want to split it? Well, Al kind of makes it a little bit easy, only for the fact that really only two places you can split this at. For one instance, let's do this. I see a way we can split this to where now, I'm just going to try to make sure we can do that. Yes. Okay. So we're going to split this into two different shapes right here. So let's do this to kind of hammer home the point. So there's one, and the other shape would be this. Change color. So what you're doing, if you see an irregular polygon like that, or irregular form, or try to separate it into forms that you know, squares, triangles. We start with squares. Squares are the easiest ones, to find the area for. But I mean, you can change them into triangles, squares, trapezoids, hexagons, octagons, parallelograms, all that kind of good stuff. So what we've done is we've split this L for the yard into two now forms that we do know of. We see a rectangle over here. We see a rectangle, and we see more than likely what is another rectangle over here. So we got to say, well, how do we find? In this instance, the question is asking us what is the perimeter and the area. If we can kind of see behind my drawing here, perimeter and area. So let's actually go a little bit more difficult here. Let's go area. So let's go area of the pink form right here. So the question is what is the length and the width? So the length and the width of this. So what's the length and the width of this figure right here? So now we see, let's kind of scroll down slightly, and I might have to rewrite this, but let's clear it. So we figured it was, so here's one. So we're going to split it here. And obviously our other figure is going to be this one. And yeah, I changed the color. So what's our length and width for this figure right here? Well, if it's 22 feet, the whole way across, so if it's 22 feet the whole way across, let's look up top. And we know that for this part right here, it's 10 feet. So if that's 10 feet, we can then say that this is 10 feet from here to here. Well, what would be this other portion? Well, if the whole thing is 22 feet, so if the whole thing is 22 feet and this portion is 10, well, 22 minus 10 will give us 12. Will give us 12. We know that that dimension is going to be 12. So now we got to figure, well, what's our other dimension here? We know that this is 12. We know that this is 12. So now we have to find out what is this. Well, let's look. If the whole way across is 18 feet, if it's 18 feet the whole way down, and we know that this that's running parallel to the other side of the rectangle is running parallel, is 10 feet, we can then figure that this is going to be what 18 minus 10 is. 18 minus 10 is 8. So is 8. So let's get rid of here and let's make it 12 times 8. 12 times 8. So now, with that being said, you should be able to figure the answer to this question. Let's get the extra writing out of the way. So we can do this. We figured out that the pinkish form that we just had here was 12 and 8 for our length and our width. So 12 times 8. So we find area. Area is length times width. Area is length times width. Ooh, go back. There we go. Area is length times width. So 12 times 8 is going to be 96. So 96 will be the area of the pink square. And in the yellow square, we find our 18 and our 10. Well, 18 times 10 is going to be 180. So your area for the yellow rectangle there is 180. And simply put, the area, you are adding both of those together. So you're adding both of those together. And just for the sake of time, let's bring up the good old calculator, and we're going to say, well, 180 plus 96 is going to give us 276. So the area of this crazy Miller's yard here is 276. So the question is 276 what? So those of you who were with me going through with this, kind of trying to hammer home that point of saying 276, not just feet, but it's 276 square feet. And I used the term in class when I was talking about this to where, in my middle school journey, I remember one of my math teachers telling me, saying, well, you always would say, it's 276 what? If you don't label it correctly, then it's incorrect. You have to label it correctly, and it's not 207, because what is it? If you just put 276, then it's 276. You could say 276 inches, miles, yards, centimeters. I mean, you have to have the correct label on this. And again, with area, it's squared feet. So in this instance, 276 squared feet. 276 squared C. And then, I mean, simply put the perimeter of this. So the perimeter of this right here, you're just adding the sides, everybody. So you're just adding the sides. So let's get rid of our extra little writing here. And a lot of times, if we've found the area, there's a reason why I did area first, because you're able to find, it's just my own specific nuance. You find the harder part first, because usually what will happen is you're able to then find some missing sides when it comes to irregular polygons and all that kind of good stuff. The only thing you have to find now, is, well, what is the other side of our rectangle here, which is 12. So, simply put, all you're doing is adding your sides up. So if you have, let's start up here. So we have 10, and we're going to move down this way. So 10, 18, and then 22, 18 to 22, then 2, over to 8, up to 12, and then to 10. Simply put, add them up. Remember, perimeter is what is the measurement around something. So like in the instance of I don't know if you can see my paper here, the perimeter is what is, you can still hear me, the perimeter is what's around, the measurement around the paper. Area is what is covering something, perimeter is what's around it. So if we add these up, up, 10 plus 18 plus 22 plus 8 plus 12 plus 10 will give us 80, right? 80, and again, have the right label, 80 feet. 80 feet. 80 feet will be your answer on that. 80 feet will be your answer. So just because I cannot find, I want to make sure that I'm good with this. So we're good. Cool. So that, my friends, is dealing with Miss Miller's front yard on this. When you're calculating perimeter and area on this. So, and again, it tells you down here to find the perimeter, add the length of all sides to find the area, multiply length and width. It tells you there, these packets do help you very much so, which is always very, very good. Just very, very good. So, let's see. Let's take a little bit of a, let me zoom out a little bit. So in that same packet, so it says there's sale signs. Jacob, so this is page 47 of that yard sale packet. So Jacob made yard sale signs for some of his neighbors. Each sign was a different shape. It says to identify the shapes. Write the name of the correct shape under each sign. It says write the family names. Write the family names on the correct signs. I certainly hope with all of the, especially the intervention work with shapes and dodecagons and all these kind of good shapes, that this should be simple and be done in about 30 seconds. On this, the Joneses family sign is a square. Which one is a square? The Joneses family sign is a square. The Joneses family sign is a square. The Lopez's family sign is a pentagon. A pentagon has 5 sides. Lopez's family sign is a pentagon. The Lee's family sign is an octagon, octagon, octuplets, octagon, eight sides for the octagon. So you look 1, 2, 3, 4, 5, 6, 7, and 8. That would be the Lee family sign is an octagon. The Brown family's sign is a trapezoid. Remember with the trapezoid, a trapezoid has one pair of parallel sides. It is a parallelogram with one pair of parallel sides. So in this specific instance, our pair of parallel sides are right here. All right. Our pair of parallel sides, as I say, use my P's anymore. The Browns would be this trap. The Galloway family sign is a hexagon. Hex, 6. Hex is 6 sides. 6 sides, or the 2 that are left. 1, 2, 3, 4, 5, and 6. That would be the Galloway's has hexagon. And just by process of elimination, the Gonzalez's family sign is the rhombus. Is the rhombus. 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 That sounds like doing a little bit of a dance right there. No, a rhombus. A rhombus. That is your last one. I hope that should be simple. I would hope that's simple. Again, I've seen some of the tests from intervention. Those of you who got this know that that should be cake to do this right here. Let's see if I can get anything else here real quick. Check the chat real quick. Hello again, yes. Let's see. Clear my screen. Oh, yeah. Oh, there you go. Yeah, transformations. So you look at each pair of shapes, determine how the shape is transformed from the one on the left to the one on the right. And it tells you, is it turned? You're going to say it's going to be rotated, translated, or reflected. Is it rotated? Is it rotated? Is it translated? Translated? Or is it reflected? And you'll see down at the bottom here, it gives you your kind of the layman's terms of what each of these math terms are going to be here. I know our eighth grade friends here dealt a lot with that recently, with making drawings and all that kind of good stuff. I remember everyone made something of like I think it was the handsome Squidward, the handsome Squidward dilation. We did the Homer Simpson, I think it was called the Kissing Homer, or half of Homer. When you flipped it on the side there, when you flipped it, and it looked like Homer was kissing himself, which was very an interesting drawing, but yet kind of showed the concept very well. But in this instance, so say like number 4, so you look at number 4 and you say, well, was it slid? So did 4 slide? Did 4 get reflected, or did it get rotated? And the thing is when it comes to number 4, I mean, you can say that this is reflected because it's in an instance to where it reflected. It's almost like saying it was reflected over, say, the x-axis. You can also say it was rotated. You can also say it was rotated as well too. It can be rotated 180 degrees. So if you're looking at what's the proper, what's the proper answer on this, number 4 should be both rotated. Let me actually clear the screen. Should be both rotated, so it's rotated, and reflected. It can be more than one thing in that instance. Rotated and reflected. And as you see, I can't draw in the small little part right there. Let's take one more. Take the easy one here. Take the easy one, number 3. Basically, is it translated? Is it translated? Is it just moved? Does it stay in its same, what they call the orientation? Does it stay in its same orientation when you slide it? So when you slide this, it stays in its same orientation. Does it do that? I mean, that's translation. Translation is just moving, but not rotating or reflecting. So it's not rotating or reflecting. It's just staying in its own same part. Now, if I took a pen and I said, well, now let's rotate the pen. Let's rotate the pen 90 degrees, 180, 270, and then back to our 360. 360 degrees creates our full circle. And then obviously reflected, if I can hope that I get this, try to do this real quick. Full screen. So with my pen here, bear with the screen, but with the pen, a reflection is flipping it down. Now, as you see, what I was with that one answer, if I reflect the pen, I'll do this real quick. If I reflect the pen, down, I reflect the pen down. Means I can also, with the answers to that question, I can rotate it down as well too. You can rotate, but you can also reflect. Those are the 3 things: reflect, rotate, translate. Again, reflect is flipping it down. Rotate is basically turning the knob, if that's the way to say it. And then translate is just taking it and you're sliding. And then everyone's favorite, which is not on this, which is dilation. Dilation is starting small and getting bigger, or starting big and getting smaller. With that being said, if there's any questions throughout this week with anything coming up with the packets, if there's any questions with the packets, please reach out via Google Classroom. Reach out and let me know. Yes, Homer, exactly. I think you had seen Homer. You had seen Homer with the kissing Homer. It was actually a pretty good picture. It showed the reflection very well. As interesting as that was, anything that kind of makes it look good. But with that being said, hope this helps. That's 3 packets we went over this morning. One was yard sale, the other was the play ball packet, and the other was the Aloha packet. Check the channel if you had joined this, or look for the specific one you need help with. Obviously, reach out to myself, reach out to anybody when it comes to doing these packets. Like I said on the previous stream or earlier this stream, depends on what it is. I do have the app access to the Google Classroom. It shows I can be able to see if you post something. I'll get an email and be able to just kind of go right in there and respond, and you can see my my certain postings that I have right there. I mean it's a very quick response. Some of you have sent me emails. I'm all for whatever works best. Send me an email, reach out via Google Classroom. You saw I posted a few videos as well too. I said, hope it helps. We're definitely in a new time frame with everything going on in this world. So with that being said, stay safe, stay healthy, make good choices, guys. So I'll see you guys later. Have a good one.